Okay, so the first example is going to be the fifth one off of that worksheet. Oops, here we go again. The fifth one off of the worksheet, and we're going to talk about Carol, and we're going to talk about Linda. So it says Carol is twice Linda's age. What time frame are they talking about? They're talking about the present. In 6 years, the sum of their ages will be 30. What time are they talking about then? In the future. How old are they now? So you're always going to be solving, well, I shouldn't say always. Generally, you're going to be solving for their current ages. So in my chart, I've got two people, Carol and Linda. So they're going to go vertically. And then I'm going to create, in this case, they only talk about their ages in 2 times. So I'm going to create 2 columns. First column is always age now. Second column is age in 6 years. Now, when I do this, I always pick variables that make sense to the unknowns. So Carol, I'm going to use a C, and Linda, I'm going to use an L. Now, if Carol is C now, how old will she be in 6 years? C plus 6. And Linda in 6 years will be L plus 6. All right, so now we're going to go back and translate each sentence. So it says Carol is. The is tells us present tense. So we're going to use the variables from present tense. And the reason why they both are is because if you look at Linda, it doesn't mention anything differently about her age. It doesn't say in the past, in the future. It just says Linda's age. So the assumption is same as Carol's age now. Okay, so what we're going to write for that, Carol, C, is equals twice Linda's age, 2L. All right, looking at that, what do you think we're going to do to solve our system? Yeah, we've got one variable already solved alone. So now we go to the second equation, in 6 years. That says what I want you to do is use these definitions for the people. And notice that it says in 6 years the sum of their ages will be. So that's talking about both of them being at the same time frame and that being in a future time frame. So the sum of their ages, well, Carol in 6 years is C plus 6. And then we're going to add her age to Linda's age in 6 years, which is L plus 6. And that's going to equal 30. Now, do I need to use those parentheses around Carol's age in the future and Linda's age in the future? Yes or no? Yes or no? I'm not hearing anything. Do I need those parentheses around Carol's age in 6 years and Linda's age in 6 years? The answer is no, not in this case. And the reason why I put them there is so that you can see the difference between a plus that goes with someone's age and a plus that goes with the word they told us, which is the word sum. That sum goes with that plus. Okay? So you don't really need those parentheses. Now, here's the interesting thing. Can I already start doing substitution? Do I need to simplify first? Okay, the answer is I don't need to simplify first. I've got C equals 2L, so I can take the expression that represents C, and I can substitute it in for C in the other equation. So that gives me 2L, and then the rest of it would be plus 6 plus L plus 6 equals 30. Now I'm going to go ahead and combine up like terms. 2L and L is 3L. 6 and 6 is 12 equals 30. And then I just start doing opposite operations. It's a single variable equation. I'm going to subtract 12 from both sides. I get 3L equals 18 divide both sides by 3, and I get L equals 6. Now I'm going to take that answer and I'm going to substitute it back into either original equation and solve for the other person. So I have C equals 2 times 6, or C equals 12. So right now, here's what I have for my answer. I distinguish who's who, and I spell out their names. Carol equals 12, and what's the label I add to that? Years. We measure age in years. And then Linda, we got to be 6 years. Now before I say I'm good, I'm going to go back and check this. Now I don't need to check back in the C equals 12. I just used that equation to get Carol was 12. So where I'm going to substitute into is I'm going to go into this equation. So I'm going to take 12 plus 6 plus 6 plus 6. Question is, does that equal 30? So let's see, I get 18 and 12, and I get 30 equals 30. So what that says is this is correct. Okay? So again, even with word problems, I can easily check my answers. All right, let's go to the next one. So this is going to be, oops, sorry. What is the problem here? Sorry. This is going to be number 6 on your sheet, talking about Bob and Mary. So 6 years ago, Bob was 3 times as old as Mary. 4 years from now, he will be only twice as old as she will be then. Find their present ages. So how is this problem different from the last one? Henry?
We don't have like a present, we don't have really an equation for their present age.
Yeah, they say nothing about their ages currently. They do talk about their ages 6 years ago, and they also talk about their ages 4 years from now. So that's kind of strange. So do we need to include their present ages in our chart? What are we solving for? What did they ask for? They need their present or current ages. So yes, that is always going to be part of our chart. Regardless if we're going to write an equation of their ages now, we have to put their ages now in the chart. So our chart includes our 2 people, Bob and Mary. And the first time frame is always the same, age now. That's where we're going to get our variables from. Then they talk about age 6 years ago. So what are we going to do with their current ages to get their ages 6 years ago? We're going to subtract 6. How about age in 4 years? And what are we going to do to their current ages to get their age in 4 years? We wouldn't add 6. We're going to add 4. So again, I'm going to choose variables to represent the people so I can track it. Bob's going to be represented by B. Mary's going to be represented by M. Okay, how do I define their ages 6 years ago if they're currently B for Bob and M for Mary? Bob would be what? B minus 6, and Mary would be M minus 6. All right, how would I describe their ages in 4 years if they're currently B and M? What would Bob be? B plus 4, and Mary would be M plus 4. All right. Now, reading the first sentence, it deals with that notion of 6 years ago. Bob was 3 times as old as Mary. Now notice that when they talked about Mary, they didn't say anything about her age. So the assumption is she's at the same time frame that Bob is. So that means when we write this equation, we're going to take it from the 6 years ago column. So what was Bob 6 years ago? Was reinforces it's the past and also tells us equals. And then it says 3 times as old as Mary. Well, 3 times is pretty obvious, but what was Mary 6 years ago? Now, because Mary is a quantity, we need to keep parentheses to keep her quantity together. So our equation for the first sentence is b minus 6 equals 3 times the quantity m minus 6. All right, now let's look at the second one. It says 4 years from now. So that says I want you to take information from the 4 years ago. It says he, meaning Bob, will be only twice as old as she will be then. So again, what it's telling me for sure is that we're talking about both of them in the future. Now, I'm going to be honest with you. There's some questions on your worksheet where it talks about one person in the future at the same time they talk about one person in the past. So you have to read carefully where you're going to take things from. So in this equation, he, Bob, in 4 years is b plus 4, will be equals only twice as old as she will be. Twice is 2 times, and because she's a quantity, we still need to keep those parentheses. All right, now here's the problem I have. That's ugly. So how do we get rid of ugly? Let's get rid of the ugly. Let's distribute. So for each of them, top one, we get b minus 6 equals 3m minus 18. Here's the caution with b's and 6's. You got to make sure they don't look the same. I'm going to go ahead and solve this equation for b. So I'm going to add 6 to both sides. And that gives me b equals 3m minus 12. Okay? Now, I'm going to also take the second equation, and I'm going to simplify it. b plus 4 equals 2m plus 8. I'm going to subtract 4 from both sides, and I get b equals 2m plus 4. And then I'm going to use substitution. And it doesn't matter which direction I go, because I have both equations are solved for b. So I'm going to take one expression that represents b and substitute it into the other equation for b. So now, this is where I'm at. 3m minus 12 equals 2m plus 4. So I'm going to go ahead and solve this. I'm going to do opposite operations. I'm going to get the m's on the left by subtracting 2m from both sides. Add 12 to the right. Get the constants together. When I solve, I get m equals 16. All right, so now I believe I found Mary's age. But I want to figure out Bob's age. And here comes the problem. I have to plug Mary's age into one of the original equations. The reason for that is because if I had made a mistake on Mary's age and I plug it back into, if I had made a mistake on the simplifying, I'm not going to catch it unless I go and check my overall answer. So I'm going to take this answer and I'm going to substitute it into either of the original equations, and I'm going to choose this one. So I get b plus 4 equals 2 times 16 plus 4. Simplifying, I get b plus 4 equals 2 times 20. And I get b plus 4 equals 40. Subtract 4 from both sides. And I get b equals 36. So right now, my two answers that I think I have, let's see, I'll just put them over here. Bob is 36 years. Mary is 16 years. So now I'm going to double check. Now I've just plugged Mary's age into the green equation. So I'm going to plug both of their ages into the red equation, the top equation, and see what I come up with. So I'm going to take this guy and plug in both answers. So is Bob minus 6 equal to 3 times the quantity Mary minus 6? So I get 30 for Bob, and I get 10 over here, and 3 times 10 is 30. So that pretty much says, yep, those are the answers. Bob's going to be 36 when Mary's 16. Okay? All right. And what's, kind of a fun way to do it, if you add 4 to each of their ages, what do you get? Bob would be what in 4 years?
40,
And Mary would be what in 4 years?
20.
Is 40 twice 20? Yeah, so you can check it that way as well. All right, we've got one more for you. And this is going to be the number 5. Now, the reason why I wanted to put this one, I wanted to put this one on here was the fact that we have some fractions. How do you deal with that? 5 years ago, Charlie was 2/3 as old as Don. Ten years from now, he will be, meaning Charlie, 5/6 as old as Don. How old is each now? So this question is somewhat similar to the last one in that it doesn't talk about their ages now. It talks about their ages 5 years ago, and it talks about their age 10 years from now. So it's talking about their ages in the past and in the future. What is similar to the last problem is when they talk about the age in the past, they're talking about both people in the past. When they're talking about their age in the future, they're talking about both ages in the future. Okay? Again, in the worksheet, there's going to be some where an age comes from a present tense or past tense at the same time you're talking about somebody in the future. So we got Charlie and Don, and we always, always, always have age now. And then specific to this problem, we have age 5 years ago. And then we have age in 10 years. So I'm going to let C and D represent Charlie and Don respectively. And how would I show their age 5 years ago? What would I do to their current ages? I'm going to take away 5 from each of their ages, and that represents their past. And how would I show their age in 10 years? I would add, 10 to both of their ages. So we give C plus 10 and D plus 10. All right, now I go and read 5 years ago. So what that says is what I want you to do is look at your definitions from 5 years ago. Charlie 5 years ago was C minus 5. Was equals 2/3 as old as Don. So we're talking about Don in the past as well. So he's D minus 5. So that takes care of the first equation. Second equation, 10 years from now. So it says, look at the definitions from the 10 years ago column. He, again talking about Charlie, he's C plus 10, equals 5/6 as old as Don. Now Don at that point is D plus 10. All right, what do you think would be a good first step in both of these equations? No, I don't think distribution would be a good first step. Let's not get rid of variables. We can't do that. Let's get rid of the fractions. So I'm going to multiply the top equation, anything that's outside parentheses, by 3. And in the bottom equation, anything that's outside parentheses by 6. So the top equation becomes 3c minus 15, equals 2 times the quantity D minus 5. And the other equation becomes 6c plus 60 equals 5 times the quantity D plus 10. So now I'm going to go ahead and finish solving these problems. Now I distribute. 3c minus 15 equals 2D minus 10. I'm going to do standard form, so I'm going to subtract 2D from both sides and add 15 to both sides. What that allows me to do is to get rid of the 15s on the left and the 2Ds on the right. giving me 3c minus 2d equals 5. The other equation, we get 6c plus 60 equals 5d plus 50. Same thing, c's and d's together, doing opposite operations. Constants together, doing opposite operations. So I get 6c minus 5d equals negative 10. All right, so I'm going to take those two equations, put them up at the top, and we're going to have to figure out what to do to get a match. And pretty much, we have worst case scenario. No coefficients that match, no signs that are opposite. But we actually we're a little lucky. I can multiply only one equation by a value to get a match. What equation would I multiply by, and what would be the number I'm multiplying by to get a match? Flint? Actually, going to go a little bit more. Multiply by negative 2. Okay. All right, so all I need to do is multiply that top equation by that negative 2, and now it becomes negative 6c plus 4d equals negative 10. So when I add the two equations together, the c's eliminate, I get negative d equals negative 20. Divide both sides by negative 1, and I get d equals 20. I'm going to substitute that back into either original equation and solve for Charlie's age. So I'll just plug it in here, and I get c minus 5 equals 2/3 times the quantity 20 minus 5. So it's really important that you guys go back and put into it the original equations. So c minus 5 equals 2/3 times 15. 3 goes into 15 5 times. I get c minus 5 equals 2 times 5, or 10. Add 5 to both sides, and I get c equals 15. So I'm going to do a little testing here. 5 years ago, Charlie would have been 10, and Dawn would have been 15. So is 10, so I'm going to do a little check here in the center here, is 10 2/3 of 15? And the answer is yes. All right, in 10 years, Charlie would be 25, and Dawn would be 30. Is 25 5/6 of 30? And the answer is yes, it is. So my two answers is Charlie is 15 years, and Dawn is 20 years. And there you go.